Okay, here we go. Writing the equations of lines flipped lesson number 6. So in this lesson, we're going to be looking at scatter plots. And scatter plots aren't perfectly linear, but they represent data points that form something that could look like a line, right? We'd look at these dots and we think, well, if we can't exactly connect them and make a line, but we could go ahead and draw a line that would represent their pattern, right? And so it's tough for some people to think about what we're actually doing. So I came up with something. Imagine instead of dots, these are all little ants. Okay, it's kind of tough to make these dots into ants, but just pretend they're little ants. And they're getting into your pantry. And you want to take your little squeeze bottle of ant poison. Sorry, this is getting a little violent here. And you want to draw a line. You want to squeeze out a line of ant poison along the path that the ants are traveling. The ants don't travel in a perfect line, but if you've ever noticed ants, they do travel in a linear pattern, right? They might not be marching right behind each other, but they're marching pretty close to a set linear path. So imagine that you want to draw a line with your ant poison that would be in close proximity to the path that these ants are marching along in. So maybe that helped you, maybe that grossed you out, but this is what we're going to do. Whether you want to think of these as data points or little ants, what we want to do is find a line, draw it, and then write the equation of that line that represents the pattern that these data points are forming. So here we go. We're going to make it easy on ourselves. We're going to go ahead and pick a y-intercept that we think would work. So when I'm looking at this graph, I realized I can choose a y-intercept either 1 or 2. Something about 2 is really speaking to me. And I'm going to go ahead, and you guys would get your rulers out. I'm going to get my straight line out, and I'm going to go ahead and see if I can do a line that looks, there we go. That line, yes, I have a few ants that are below and a few ants that are above, but that line really it represents the pattern that the ants or the data points are making. And so what we want to do after we draw our line, so right now I want you to draw a line, and I want you to make sure that you make sure that your line starts at the y-intercept of 2 and that it goes through the corner point 6, 6. And so does it have to go through that same corner point? Well, while we're working together, yes, because I want us to get the same answer. But when it comes time for you to practice or when you do these on the test, we're going to get different answers. They're going to be close to each other, but they're not going to be exact, and a lot of answers will be correct, even though they look different. Now, we did happen to use a point that was already there, and that's fine. We can do that. Sometimes we're going to go ahead and, oh, I'm not sure what happened there. Sometimes we'll use a point. Sometimes we'll use a point that's not there, and we'll have to, all right. Let's go back there. All right, so now we're almost done. We've got a y-intercept. Our y-intercept is 2. We have our slope, which is rise, 1, 2, 3, 4. Run, 1, 2, 3, 4, 5, 6. We've got our slope then, that's 4 over 6. We could also have noticed, oh my gosh, look at this. We had another corner point right here, which would be up 2 over 3, up 2 over 3. So let's go ahead and simplify the 4 over 6 to 2 over 3. Let's put it together. We know that we can write the equation of the line in slope-intercept form. So our slope is 2. I'm sorry, our y-intercept. Wow, I almost just made a mistake like some of you do, and that's okay. We can make mistakes and then catch ourselves. Our slope is 2/3, and our y-intercept is 2. And this is the equation of the line that represents the pattern of these data points. Or if you want to think about the ants, this is the equation of the line that would represent the line of ant poison that we would put down so that the ants could be in close proximity to it. All right, let's try another one. So once again, we're going to be doing two things. We want to draw a line that represents the pattern of these data points. So we wouldn't just go, there you go, there's a line. No, that doesn't represent these data points at all. And certainly if they were ants, they're really not going to be attracted to this line of ant poison. So we want to make sure that our line of best fit that we draw has a negative slope that goes downward, and we want to pick a reasonable y-intercept. And so when I look at this, I see that 10 would make an ideal y-intercept. I could start my line there. Let me get my line out. You guys get your rulers out. So I could start my line there and go through, let's see if I did this. That looks pretty good, right? I have a few data points above the line, a few data points below, so that represents something that looks reasonable. And I notice that I have a corner point right here. Now, once again, the corner point was actually one of the data points that we had. It doesn't have to be that, but so far we've had two examples where it is one of the data points. So here we go. We've got our y-intercept, right? So our b is 10, and we can figure out our slope, right? Our rise is 1, 2, 3, 4, 5, 6. Our run, 1, 2, 3, 4, 5. So our slope is up 6/5, but we stop and say, if we were to sign our name on the line, that slope would be negative. We're going to put it together. Our slope is -6/5. We put the x after our slope. There's our y-intercept. This is called the line of best fit. This is the line that represents the data points that were given in our scatter plots, the general pattern that the data points are showing us. All right, let's try another one. Wonder if this is a little different, right? Here we notice that the scaling is a little different. In number 2, our x-axis was going up by 1s, right? 1, 2, 3, 4, 5. Our y-axis also was going up by 1s. 1, 2, 3, 4, 5. But we have to notice that here in this graph, our x-axis is going up by 2s, right? 10, 12, 14, 16, 18. And our y-axis is going up by 100s. So the scaling is different, and we're going to have to be very careful. So what do you guys think? We could use 0 as an x-intercept, but I think a more appropriate one would be to pick 100. So that's really your first step, to decide what y-intercept you could use as your starting point to make the line. So let's go ahead and get out your rulers, and let's try to create a line that starts at 100 and goes through these data points, and make sure we include one corner point. So finally, we see a line. This is pretty good. We've got some above, we've got some below, but this line represents the pattern of these data points, or the pattern that the ants are walking in, right? They're walking in, not a straight line, but they're walking in somewhat of a linear pattern. So let's go ahead and notice that we have a corner point right here, right? And that wasn't one of the original data points, and that's okay. So once again, our first step is to pick a y-intercept. That could be the start of our line, of a reasonable line that would match our data points, the pattern that they make. And we need one other point. We need a corner point so that we can find the slope. And so let's go ahead and see. Our y-intercept is 100. And our slope, now watch, when we do our rise, we know that we're rising by 100. So that's 100, 200, 300, 400. So our slope is going to have 400 on the top. And then as we run over, we're going to count by 2s. So when we jump, we say 2, 4, 6, 8, 10, 12. We get to our point, 400 over 12. If we put that in the calculator, we're going to get, what, 33.33333. 33.3 is good enough. And now we're done. The only thing we have to do is put the slope in front of the x and put the y-intercept at the end. And this is the equation of the line that matches the pattern that these data points make. So you know what, I'm going to keep repeating myself, right? We've got one more. I'm going to repeat the same thing, but I kind of want to show you some ways to not do it real quickly. Now that you know the way to do it, I want to show you some lines that just wouldn't work. For instance, so once again, this I'm showing you things that wouldn't work. What if you decided that you wanted to make 80 your y-intercept? There's no way we could make a line, if 80 was our y-intercept, that would represent the data points, right? All those data points are way below. And if these were ants and they kept on marching, they're marching this way. Okay, they're never going to decide to go that way towards the line. They're marching this way for the sugar, whatever you have in your pantry, right? So that's bad, right? So we don't want to do that. All right, let's do another one that would represent something that's the wrong way to do it. Wonder if you decided that you wanted 55 to be your y-intercept. And your line, now we could make a decent line here, but wonder if you're like this, right? That's not a good line. Or wonder if you're like this. That wouldn't be a good line either. So, and I think 55, no matter what we do, let's see if we move, let's see, whoops, let me go back. If we started at 55 and we did this, I think that's reasonable. We could do that. I'm going to go ahead and pick 65 instead, but once again, you could pick 55 and you could be just fine. Your answer would be correct on the test. I want you to notice your answers on the test are going to all look different from the people in your pod, from the people in your class, but they could still be describing correctly the pattern. So when we look at this, I'm going to go ahead and pick the y-intercept of 65. Once again, I think you could pick 60. I think you could pick 55. But I'm going to go with 65. I'm going to take out my ruler, and I'm going to draw a line where, let's see, where am I going to make my corner point? Okay, I got a corner point. So here, I think this represents the slope, the steepness of this pattern, and I think that we have enough of the dots above and enough of the dots below to say, yeah, this is a reasonable line. We also have a y-intercept right here. So here we go. We know that we have a corner point right here. So our y-intercept is 65. And our slope, now once again, we have to pay attention to scale. So as we jump up, the y-axis, we're jumping up by 5. So we'll say we're jumping up 5, 10. So our slope, our rise will be 10. And then we need to pay attention to our scale of the x-axis. It's just plain old, we're jumping by 1s like normal. So over 1, 2, 3, we have 10 over 3. If we want to change our slope into a decimal, we can. So we can do 3.3, or you could keep it as 10/3, right? We could write it as 3.3x plus 65, or you could write it as 10 over 3x plus 65. I want to show you real quickly what would have happened if, so you got this down, I want to show you real quickly what would happen. Okay, line, can you come off? Awesome. Why don't I show you what would happen if we picked a different y-intercept? We could pick 55. We could find our ruler. We could choose, let's see, this is looking pretty good. I need to make sure I have a corner point. Can I get a corner point? That looks reasonable. So once again, I have a y-intercept, 55. I have a corner point here. I would find the slope. Up 5, 10 over 1, 2. So this time my slope would be 5, right? And my y-intercept would be 55. So I just wanted to show you, before we had the line y equals 3.3x plus 65. Either one of these correctly describes the pattern. So both of those are correct. And we could even get a third equation that would be correct, or a fourth equation. So I just want you to be aware of that. Your answer may not look like your partner's answer. All right, well, hopefully you get more practice with this, and I want to thank you for joining me, and I will see you in class.